Welcome everyone. We are discussing maximum and minimum value of a function. In the first two classes, I have discussed how to find maximum and minimum value using first derivative test. Now today I will discuss how to find maximum and minimum value using second derivative test. So you always use second derivative test for problems of board. So today I will discuss only for board problem. So you look, I have already discussed for maximum or minimum value, card will be of this type. This one or this one. Now, look, if it is x equals to a, then in the neighborhood, this is a minus h, and this is a plus h. So, if function is y equals to fx, then it is fa. It is f a plus h, and it is f a minus h. So, fa is greatest. Look, fa is greatest. So, fa and fa also greater than fa minus h. In neighborhood of a, fa is maximum. So look in figure, if you consider this as fa, now look, this is fa plus h, it is fa minus h. Similarly for this figure also, in the neighborhood of a, fa is the greatest value. So this is fa, it is greater than fa plus h, and simultaneously fa is greater than fa minus h. Look, this property is true for the point A only. If you go, so at the point, suppose this is A, this is A. If you consider a point taking here, suppose x equals to b, then this property is not satisfied. That is why this type of maximum or minimum value is known as local maxima or local minima. Local maxima or relative maxima. So relative maxima or local maxima. So unless otherwise stated, by maximum or minimum value, we always mean local maxima or local minima. So if you get, I have already discussed this type of curve, you get maximum and minimum value. Now for at x equals to a, look, pt tangent, pt is tangent. So tangent is, pt is parallel to x-axis, and we know dy dx equals to 0. If it is parallel to x-axis, dy dx equals to 0. Now for minimum value, we get this type of curve. Suppose x equals to b. So this is b plus h. This is b minus h. So what you are getting, fb less than fb plus h, and simultaneously fb less than fb minus h. This is y equals to fx. So this is fb plus h. This is fb, and this is f b minus h. This is b minus h and this is b plus h. So at x equals to b, tangent is parallel to x-axis. So dy dx equals to 0. In both cases, we are getting dy dx equals to 0. So that is why dy dx equals to 0 is called necessary condition for extreme value. Extreme value means maximum or minimum. So we need one more condition. To check whether the value is maximum or minimum. So this is second derivative test. Second derivative test. So what is the theory, working rule? A function f(x) is said to have maximum value at x equals to a. If dy dx equals to 0, this is called necessary condition. And double derivative at x equals to a less than 0. This is called sufficient condition. So you have to recall this. This is our working rule. Now for minimum value at x equals to b, dy dx equals to 0, necessary condition, and double derivative at x equals to b greater than 0, sufficient condition. So this is our working rule. Now I have already discussed in the previous class that there are functions for which first derivative does not exist, but the functions have minimum or maximum value. So example is mod function. This type of figure, here first derivative does not exist, but it has minimum value. And number 2, you have to remember this one, the minimum value. This is also important problem, may be greater than maximum value. Minimum value may be greater than maximum value. Suppose for this type of part, so look, here it is minimum, here it is, suppose this one, this one is maximum value, this one is minimum value. So minimum value may be, I am saying may be greater than maximum value. And I have already discussed that points obtained by putting dy by dx equals to 0 are called stationary point or turning point. And points obtained by putting dy dx equals to 0 or at points where first derivative does not exist are called critical point. So this is our working rule. Now give an example of a function for which minimum value greater than maximum value. So this is most important problem for board. So this type of function, y equals to x plus 1 by x cube plus 1 by x cube. So odd power plus reciprocal of odd power. So these are very simple and only both form. So consider 1. So you have to find dy by dx. So dy by dx is derivative of x is 1 and derivative of 1 by x is minus 1 by x square. Now d2y dx2, derivative of 1 is 0, 2y x cube, using second derivative test. Now for maximum or minimum value or extreme value, it is called extreme value, dy dx equals to 0. So this implies, so x equals to plus minus 1. We are getting x equals to plus minus 1. So therefore, the function may have, we are not sure, may have maximum or minimum value at x equals to 1, minus 1. Now you have to find second, you have to check second derivative test. So d2y dx2 at x equals to 1. So this is 2 by x cube. So 2 by 1 cube equals to 2 greater than 0. So this is sure test, positive. Therefore fx has minimum value at x equals to 1. So what is minimum value? F minimum equals to f1. So what is the function? X plus 1 by x. So 1 plus 1 by 1 equals to 2. So you are sure that the function has here may have. Now you have to check for the second point, x equals to minus 1. Now look, d2y dx2 at x equals to minus 1, at x equals to minus 1 equals to 2 by minus 1 and whole cube minus 2 less than 0. So sure condition. So fx has maximum value at x equals to minus 1. Now f maximum equals to f of minus 1 minus 2. Now maximum or minimum value is obtained by putting value of x to the original function. Now what is minimum value? Minimum value is 2. So f minimum, and what is maximum? Minus 2. F minimum greater than f maximum. So there are functions for which minimum value may be maximum value. Minimum value may be greater than maximum value. May be. So there may have functions for which minimum value greater than maximum value. Now consider maximum or minimum value. So find maximum or minimum value. Find maximum or minimum value if any. So these are all board problems. So consider problem number 3, 4, 5. They are of trigonometric function. So problem number 3, fx equals to cos to the power 4x plus sin to the power 4x. Now what is f dash x? 4 cos cube x into minus sin x. 4 sine cube x into cos x. So you can take 4 cos x sin x common. So we are getting sine square x minus cos square x. Now try to simplify it using trigonometry. Now this is 2. This one also sine 2x. 2 sine x cos x is sine 2x. And cos square x minus sine square x. It is cos 2x. So this is minus cos 2x. So again it is formula of 2 sine a cos b. So minus outside. So this is sine 4x. Now, second derivative, COD test, f double dash x minus 4 cos 4x, sin 4x, so cos 4x into 4, so minus at the beginning. Now, for extreme value, f dash x equals to 0. This implies minus sin 4x equals to 0 implies sin 4x equals to, you know, value of sin is 0 at multiple of pi. So you can write 4x equals to, so general solution is sin x equals to 0. So what is general solution? X equals to n pi. So sin 4x equals to 0. So x equals to n pi by 4. So n is integer. N belongs to I. So what are the values? If you put n equals to 0, 0, pi by 4, pi by 2, 3 pi by 2, 2 pi, so on. You are getting so many values. Now, you see the restriction. You have to take those values lying between 0 to pi. 0 to pi. So, pi by 4, pi by 2, n equals to 2, pi by 2, n equals to 3. So, this is 3 pi by 4. 3 pi by 4. 3 pi by 4 and 2 pi. So n equals to 3, 3 pi by 4. So these are the values. But you have to take those values lying in the interval 0 to pi. So pi by 4 is 1 value. Then pi by 2. Then 3 pi by 4. Then 3 pi by 4. So these are values lying in the interval. So you have to verify double derivative at these points. So now verify double derivative at these points. So f double dash 0, f double dash 0 minus 4 cos 0. So minus 4 less than 0. So fx has maximum value at x equals to 0 because second derivative test is negative. Now what is maximum value? F maximum equals to f0 equals to sine to the power 0 cos to the power 4 0. Sine 0 is 0, so this is 1. So maximum value is 1. Now for pi by 2, f double dash pi by 2 equals to minus 4 cos 4 into pi by 2 is 2 pi. 2 pi. Four into this is cos pi. 4 into pi by 2 is cos pi. So minus 4 minus 1. So 4 greater than 0. So fx has minimum value at x equals to pi by 4, not pi by 2, sorry, pi by 4. Fx has minimum value at x equals to pi by 4. Now what is minimum value? F minimum equals to f pi by 4. So cos to the power 4 pi by 4, sin to the power 4 pi by 4. So 1 by root 2 whole to the power 4, 1 by root 2 whole to the power 4. So this is 1 by root 2 whole to the power 4. So this is 1 by root 2 square is half. So 1 by 4 plus 1 by 4. So this is half. This is cos to the power 4 pi by 4. 1 by root 2 whole to the power 4. Root 2 to the power 4. So root 2 to the power 4. So this is 2 square equals to 1 by 4. 1 by 4 plus 1 by 4. So 1 by 4 plus 1 by 4. So you are getting half. So a minimum equals to half. Now look, you have to verify pi by 4, pi by 2, not 0. So I have already, so this one, this is not in the interval of 0 is not included. So no need of finding 0. But if it is given that 0 less than equals to x less than pi, then you have to take 0. So what are the stationary points? Stationary points are 0, pi by 4, pi by 2, 3 pi by 4, 3 pi by 4, pi and so on. But you have to see the stationary point in the restricted interval. So stationary point is only pi by 4, pi by 2 and 3 pi by 4. So you have to check, verify at these points. So it is stationary point but not included in this interval. Similarly, you can verify double derivative at pi by 2, 3 pi by 4 and you complete this. Now, problem number 5. So this is very simple problem, 2 cos x plus x. So look at the restriction. Now f dash x equals to minus 2 sin x plus 1. Now what is f double dash x? Minus 2 cos x. So f dash x equals to 0 implies 1 minus 2 sin x equals to 0. So sin x equals to half. So in 0 to pi, sin is positive in first and second quadrant. So x equals to pi by 6, 30 degree, and pi minus pi by 6, 5 pi by 6. Or you can find general solution, then put particular values of n. Now sin x equals to half, it is in first and second. So you are getting 2 stationary points. Now f double dash pi by 6 minus 2 cos pi by 6 minus 2 cos pi by 6 is root 3 by 2 less than 0. So fx has maximum value at x equals to pi by 6. What is maximum? F maximum equals to f pi by 6. So 2 cos pi by 6 plus pi by 6. So pi by 6, 2 into root 3 by 2. So you are getting this as maximum. Now one more point is remaining. So f double dash 5 pi by 6 equals to minus 2 cos 5 pi by 6. Cos 5 pi by 6 is negative in second quadrant and negative into minus 2. This is greater than. So fx has minimum value at x equals to 5 pi by 6. So f minimum equals to f 5 pi by 6. Minimum is obtained by putting value of x to the original function. 2 cos 5 pi by 6 plus 5 pi by 6. So cos 5 pi by 6. So cos pi minus pi by 6. So minus cos pi by 6 plus 5 pi by 6. So 5 pi by 6 minus 2 into root 3 by 2. So 5 pi by 6 minus 5 pi by 6 minus. So second derivative test. You always use second derivative test for both points, algebraic and. So today I have discussed how to find maximum and minimum value using second derivative test. Using second derivative test. For trigonometry function f dash x equals to 0, so find value of x. You may get value of x from general solution or from your idea of if restriction is given quadrant. Then check second derivative at the specified point. If it is greater than 0 minimum, less than 0 maximum. And maximum and minimum value will be obtained by putting the value of x to the original function, not in derivative. Not in derivative. So you practice problem number 2 and problem number 4. So these are basic problems. Thank you.